last identity right here. Last identity, the cofunction identity. And the reason that works is because if we think about the unit circle right here, here at 30 we have the point root 3 over 2, 1/2. That's at 30 degrees. And at 60 degrees we have the point 1/2 root 3 over 2. So all it's saying is 30 and 60 are complementary. If we add them together, we get 90, right? So if we take 90, if we take the sine of 90 minus 30, the sine of 90 minus 30 is going to be the same as the cosine of 30. Or the cosine of 60 is the same as the sine of 30. And that happens with complementary angles. Okay? If you are just done memorizing, you're like, I cannot memorize anything else, then you don't ever have to know the cofunction. It just makes it easier. It makes it one step instead of having to expand it using the sum and difference. Okay? It works exactly the same with the sum and difference. You just have to do expand it, evaluate, combine like terms, multiply, and then you have your answer. So it's just a shortcut for when you have 90 minus x or pi over 2 minus x. It works for that because, again, the cosine of 30 is equal to the sine of 60. The sine of 30 is equal to the cosine of 60. That's why that works. All right, so this first one, I actually want you to change it so that you can see that it's the cofunction. So I think I flip-flopped those on your, if you printed your notes. So if you printed your notes, change that first example right there to be cosine of 90 degrees minus theta equals sine of theta. So these are all going to be proofs today, and the directions say to state our reasons. So we're going to prove and state our reason out to the side. If you want to prove it and then state your reasons, or you want to start working and state your reasons as you go, it doesn't matter, however you choose to do that. So because this is the cofunction ID, we can say cosine of 90 minus theta. Again, I'm looking at my IDs. I have those IDs right in front of me. I can say this is sine of theta equals sine of theta, and I'm done. And the reason is the cofunction ID. There's your reason. You're done. Left side equals the right side. Be sure that you pick one side to do something to. Pick one side or the other. Some of you yesterday, you picked one side, and then you moved to the other, and then you moved back to the other side. You're all over the place. You cannot do that. You pick a side, and that's the side you manipulate. You can never change the other side. It stays the same the entire way down. If you think you picked the wrong side, you must erase and start over. Okay, you can't just start from that point, because I'm reading it, I'm going down, and some people, very few, but some were all over the place. It was impossible for me to even know where you started, stopped, began, wherever it was. Okay, you have to be very methodical on these problems. All right, this next one. Now, this one is a little bit lengthy, but it is very easy. There is no question about what do I do. When you see a problem like this, the only thing to do is to use the sum and difference and expand it. If you have a sum and difference in a proof, you are going to expand it. And we have two. Here's one minus, here's another one. So we're going to have to expand twice using the sum and difference IDs. It's not cofunction, so we can't use that. Theta plus 60 is nothing cofunction. There's no 90 or pi over 2, so we have to expand. So just looking at my IDs, that's how I'm expanding this, straight off my IDs. Sine theta, cosine 60 degrees, plus cosine theta, sine 60 degrees. That's that first one right there. Now, minus, I'm turning a single term, cosine theta plus 30, into two terms. So minus, I have to put parentheses right there. If you don't, it is going to be wrong. You are going to mess up from here on down. Nothing else can be correct. So minus cosine theta cosine 30 minus sine theta sine 30 equals sine theta, and that was because of the sum and difference ID. That's what I did. You cannot say expand right there. You have to say you use the sum and difference ID. That's why we were able to do that. Now, this next step, you can do a couple things at a time. If you just want to do one at a time, that's fine, or if you want to do a few at a time. Now, when I look at this, I have a sine theta cosine 60. I don't have another one of those. So there's no like combining like terms I can do at this point. But I am able to know what the cosine of 60 is. I also have this negative that I have to distribute. So I'm going to do those two things at once. I'm going to evaluate and distribute that negative. If you want to make them two separate steps, you can do that, but I'm going to do them together. And because I know what those are, they're on my unit circle, I can evaluate those. Sine theta times cosine of 60 degrees, that's equal to 1/2. Cosine of 60 equals 1/2. Cosine of 60 does not equal cosine of 1/2. Absolutely, you can move it to the front. Okay, if you want to make that 1/2 sine theta, I'm going to do that in a second, but you can do that at the very beginning because it looks a little bit more normal if the coefficient's out in front. But I'm going to move there in a minute. Cosine of theta, we can't do anything with that, but we do know sine of 60 is √3/2. So same thing. If you wrote √3/2 cosine theta, that works also. Now this negative goes to both of those. So negative cosine theta, cosine of 30 is √3/2. Now this I saw a couple times. I saw people distributing negatives to like lots of terms in parentheses. Like if I had -2 times 3 times 4 times 8, do I multiply -2 times 3 and -2 times 4 and -2 times 8? No. But if that was plus and plus, then I would do that. So there's a difference, again, between multiply. If there's a number out front that's negative, I don't distribute it to each part. I distribute it to each term. This is a term minus another term. Terms are separated by plus and minus signs. Negative times negative is positive. Sine theta times 1/2 equals sine theta, and I evaluated, and I distributed. I did two things. I distributed that negative, and I evaluated. So I need to write both of those things that I did. Multiplied, you multiplied by -1, that would be okay. But you must say evaluate. There's nothing else you could say to what you did for cosine of 60 degrees. That's called evaluate. All right, so what Victoria said a second ago, she put the numbers out in front, which is fine. Okay, you can do that at the beginning, you can do that at the end, you don't have to do it at all. But before I do that, I'm going to look and see, is there anything I can get rid of? Yep, because that's 0. So I added those, subtracted those, that ends up being 0. So I'm going to rewrite this as 1/2 sine theta plus 1/2 sine theta equals sine theta, and it's because I combined, add, subtract. Combine, add, subtract are all interchangeable because subtracting is just adding a negative. Adding, subtracting, combine, all those words are interchangeable in my world, okay, for me. Now, if I have half of something plus half of something, that's a whole something. So sine theta equals sine theta. Again, add or combine. All I did was add. Add like terms. Those were like terms. I added them together. A half plus a half is a whole. Now, some people earlier, at this point right here, they said 2 sine theta 1/2. Would that be okay? And then their reason was they multiplied 2 times sine theta times a half, because they had 1 sine theta half plus 1 sine theta half, so they had 2 sine theta half, and 2 times a half is 1, and they came up with sine theta by simplifying or canceling or reducing. Bless you. So again, it just depends on what you saw, how you saw it being done. You can do it lots of different ways. On the quiz yesterday, I think it was number 2, I think so far I've seen like, I don't know, 6 or 7 different ways you have done it. Different from what I did it. Some of you did it the way I did it. Some of you did it differently. A few of you did it less steps than what I did it. A few of you did it 5 or 6 more steps than the way I did it. But it still is true. Some people did not make it true, okay? But just because you do it differently doesn't mean it's wrong. Doesn't mean it's right, but it doesn't mean it's wrong. So there are different ways to do these. All right, so this one, not quite as apparent what to do at the very beginning. And I think today alone, I've worked this probably 2 or 3 different ways. I worked it yesterday, and then this morning I worked it again, and then I worked it a different way. And then in class, I think it was even a different way. So lots of things you can do. I would definitely work with this side. Now, I saw this, like some people did this, like they would write something, I don't know, over here, and then they would say equals left-hand side. Okay, that doesn't make any sense, okay? This is the left, this is the right. So if you're going to write left-hand side, it has to be on the left-hand side. If you're going to write right-hand side, it needs to be on the right-hand side. You can't flip-flop anything. It is a proof. What you are given is there. You can't change anything. You pick one side to manipulate. So cosine 2 theta is not going to change. And I'm going to write cosine 2 theta because it's not that long to write. If you wanted to write LHS, you can. A few of you picked some different acronyms. I don't know what they meant. Okay? You either write what it is, or you write out left-hand side, or you do LHS. Those are your options. Those are your only options that I'm giving you. Someone else gives you different options, they can give you their own grade. I'm grading your tests and quizzes. I want those to be the words you use. All right, so when I look at a problem, the very first thing that I ever do is there something to factor out, or can I change 2 words into 1? If I can ever change 2 words into 1, that's what I want to do, especially because there's just one thing over here. So when I look at that, I can't change both of those. One of them is an ID, one of them is not. The bottom is the ID. So I'm going to change that to secant squared theta. Because any time I can change one word into 2, I want to do that. All right, so now at this point, I could separate it because cosine 2 theta. So if I think about my cosine 2 theta, all my IDs, because obviously it's not just going to end up being cosine 2 theta. I'm going to have to use one of them to get to. So these right here. That's probably going to be the step before I have my answer. It's either going to be cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 cosine squared. So it's going to be 2 terms, and then I can change those 2 terms into this. So the reason I think about that is because when I'm at this step right here, maybe, if we can get there, is I could split this up right now, and then I'm already on my way to getting those 2 terms. So here what I did was Pythag ID. And so what I'm going to do is cosine 2 theta equals 1 over secant squared theta minus tangent squared theta over secant squared theta. I don't know, what did I do? I split it. Split it up. Because think about this. If I had 2 plus 3 over 5, I could change that to 2 over 5 plus 3 over 5. As long as the 2 terms are in the numerator, I can do that. Again, not the only way.
If you wanted to use the reciprocal ID, do you have to distribute the cosine to the 1 and the tangent square?
Everything in the numerator. Okay? And you would have to show that in this next step. Some people were like doing this and then multiplying by the reciprocal up here, and that's not true. If you're going to show something in a step above, it has to be equivalent. Everything has to stay equal. So if you're going to multiply by the reciprocal, that needs to be your next step. So if you were going to go from this first step here to multiply by the reciprocal, this is where you show multiply by the reciprocal. You can't show it back up in here because that is not equivalent. All right. So now I can do a little bit of something, and I can do something to this and something to this. So I'm going to say cosine 2 theta because one of my cosine 2 theta is cosine squared theta minus, so there I use the reciprocal ID, and then I'm going to change tangent to sine squared theta over cosine squared theta. And I already used my reciprocal ID, so reciprocal and ratio ID. I can say up to 2 things over here per line. I use the reciprocal and ratio ID. I cannot use the reciprocal ID and multiply by the reciprocal at the same time. That's not okay. You can't do 2 things to the same thing. So I couldn't go from secant to multiply by cosine over 1. That's not a thing, because you're changing the reciprocal and then you're multiplying by the reciprocal. You can't do that. Bless you. All right, so now I can't do anything in this step. My next step, cosine squared theta, we like that there. Now I can multiply by the reciprocal. I can't multiply by the reciprocal in this step. That's not correct. Now this equals this. And that was multiply by the reciprocal. And now look, those cancel. And I have cosine 2 theta equals cosine squared theta minus sine squared theta, because I reduce, cancel, simplify, I don't care. I'm good with any of those words. Divide is actually the most appropriate word. You actually divided them. But I'm okay with reduce. Simplify goes with reduce and cancel. Simplify is not add and subtract. Someone else tells you that, that's fine. That's what they like. I don't want that. I'm not going to give you credit for simplify when you add and subtract, because really all we're doing is simplify. You could say simplify every single step. It's not the correct word that I want you to use. And now we have our ID. Cosine 2 theta equals cosine 2 theta because of our double angle ID. Not the only way to do that. You could have changed to sines and cosines at the beginning, like what Nell said. You can multiply by the reciprocal way up in like step 3 and distributed it to everything. You could have got a common denominator and then multiplied by the reciprocal. Common denominator, combine the numerators, multiply by the reciprocal. Lots of different ways you could have gone about doing the problem.
At the very beginning, could you have factored the numerator into like...
You could. So factoring that is, I did when I worked this problem a couple days ago, but it didn't, then I erased it. So there would be nothing wrong with that. You would just need to get a common denominator, like, so 1 plus tangent, 1 minus tangent, but then you would change to sines and cosines, and what would end up happening is you'd multiply them back together anyway. So in this problem, now if this squared hadn't been there, that probably would have been a good idea, because then things would have canceled. Now that would have been something different over there. But yes, that is something that is correct. But when I got to a certain point, it wasn't helping me. So, I mean, I'm sure I can. All right, number 4. So hopefully we look at that left side, and the left side is what we want to do something to. Okay, the right side is going to be what we're keeping the same. So anytime you have a double angle in a proof, you want to expand it. Anytime you have that, I would say 100% of the time, you want to expand it. Because right now, we can't do anything. We can't split this up like we could that last one, because the 2 terms are in the denominator. If we ended up with like cosine 2a over cosine 2a, that's tangent 2a. If that was there, but that doesn't help us at all anyway, because we're looking for cotangent a. All right, so double angle in a proof. Expand. The numerator is kind of nice, because there's only one way to expand that. 2 sine a cosine a, that's our only choice. But the denominator, we have 3 choices. So which one to pick? Doesn't really matter which one you pick. If you pick one of them, it might save you some steps. If you pick another one, it might add 2 or 3 steps. The other one might add 4 steps. It might subtract 2 steps. We don't know. There's no way to know. But what you can kind of think about is what your goal. Your goal is cotangent. So most likely, the step before the answer is going to be cosine over sine, because that's what cotangent is. So here we already have a cosine in the numerator, so that means we want to get that sine to cancel. And since I want to eventually get that sine to cancel, I'm going to use the cosine double angle with sines in it, which is 1 minus 2 sine squared A. And both of those things I did were the double angle ID. We did the sine double angle and the cosine double angle. And no matter what three of the three you choose, there is nothing going to be wrong with any of those three. You just might have to do some Pythagorean inside if you choose the cosine squared, okay? Or change it somehow using the Pythag ID. All right, so now I want to clean that up. Anytime I substitute, that's all this is substituting, then I want to see what I can do. So by clean up that negative, I'm going to get rid of those parentheses. So 2a cosine A over 1 minus 1 plus 2 sine squared A. Don't forget your equals cotangent A. And what did I do? I distributed, multiplied. I did not simplify. That's for canceling, reducing. Again, you could say simplify on everything, but then it'll be wrong because I simplify except for when you're reducing. All right, so now I can still do a little bit of combining that denominator. So I end up with 2 sine A cosine A. 1 minus 1 is 0. 2 sine squared A equals cotangent A. What did I do? I subtracted 1 minus 1. Add, subtract, add, combine. 1 plus a negative 1 is add. 1 minus 1, subtract, combine. Add, subtract, combine. Those words are interchangeable. So now I've gotten rid of all my plus and minus signs, so now I can start canceling. 2 divided by 2 is 1. I have a sine and a cosine, and 2 signs down here. So this 1 cancels with one of those and leaves us with cosine A over sine A equals cotangent A, and I'm fine with simplify, cancel. Really the most appropriate word is divide, but divide, reduce, simplify. I'm good with any of those words. And now there is only one reason we can do this last step, and that is the ratio ID. We can say cotangent A equals cotangent A because of the ratio ID. If you use the ratio ID, you have to say ratio ID. Ratio and reciprocal are not interchangeable at any point in time ever. They are completely different. Ratio deals with changing sine and cosine, or tangent and cotangent to sines and cosines, or vice versa. The reciprocal deals with sine and cosecant are reciprocals, secant and cosine are reciprocals, and tangent and cotangent are reciprocals. Right? So that is more proofs with the double angle and sum and difference. Now, your quiz is just over 5, 6, and 7, but remember, we just did Unit 1 stuff right there. That was from day 1 of this unit. So 5.1, none of that stuff goes away. They've gotten more difficult because we're adding more to it every day. So just be sure you keep practicing. Most of you have done a great job practicing them and doing them. Okay, so you have the rest of the class today and all day tomorrow to finish your 5.7 classwork. Okay.